All right, guys. So we can discard one of this expression. Am I right?
Yes,
What
sir.
what's next? What can we do next? What can we do next?
So distribution করা যায়.
Distribution. This part and this part is common. So
Yes, sir.
we can take this one as common. So it would become common. Become what?
Yes, sir.
So here we have this item. Here distribution of what else? What else we can do? What else we can do?
So ভিতরে আরেকবার ডিস্ট্রিবিউশন করা যায় না?
Okay, let's do that. Does it change anything? Does it change anything?
No, sir.
It will not change anything. If you distribute this, you will get a bigger expression. Ultimately,
Yes, sir.
these two terms
Yeah.
cannot be cancelled. So I think that is done. Okay, no more.
Now, J. Morgan theorem use করতে পারি.
Which theorem?
J. Morgan
De Morgan? Yes, if you apply De Morgan over here, then what happened? Then it would become Q and R not. But next time you cannot do anything. Am I right?
Yes, sir.
We cannot do anything more. So how can we connect this actually? How can we connect this? So it is something like this. Let's take this one first. Let's take this one first. So it is what? How can we represent this?
Parallel.
How can we represent this? This one is Q. This one is connected with series with R, not parallel with R. Then again, this one is series with this. This one is not Q. This one is not R. Then the whole thing is connected with parallel with P.
Parallel with P.
So this complicated circuit boiled to this one. Is it clear to you guys? Am I right or not?
Yes, sir.
So do you have any question after this?
No, sir.
Okay. So let's try. Let's start today's topic.
To finish করে নেই, নোট করে. Done, sir.
Done? Okay. So let's start today's topic, the new topic. logical inference. What do you mean by logical inference? Can you tell me what do you mean by logical inference? What do you understand about logical inference?
Idea nahi, sir.
You don't have any idea, okay? So let's consider this. X square equal to 9. Then what is
In
the value of...
logical inference, do we assume the factual thing to be true always? Like we consider it to be true?
It is nothing like that one. If you consider x square equal to 9, if you consider this, then what can you write?
X is equal to plus minus
X is
3.
equal to plus minus 3.
Plus minus 3. So, assuming this one as true, then going to this line is can call a logical inference if they are logically valid. Is it clear to you guys?
Yes, sir.
So,
Yes, sir.
x square equal to 9, we write this way. X equal to plus minus 3. Is it clear to you guys? This symbol is actually the logical inference symbol. Now tell me when this one would be true. When this one would be true. If this is the case, then when this one would be true. Logically, you have to define. If this one is true, that means if the value of this one, truth value is 1 or true, then how can you say this one is true? Is there any idea? Tell me. If this one is true, the left part is true when the right part is true. How can you use connectives to prove that?
Truth table.
Huh?
Truth table.
How can you connect with connectives? What connective should I use? These two.
So, so 3
Bidirectional.
into 3 or minus 3 into 3.
Bidirection become too heavy. Is there any light one? I do not want to prove if this one is true, that is also true. That is not my issue. I only want to prove if this one is true, this one is true. So which connector should I use?
That's
From here to here only.
Borgomol?
From here to here only. Implies, yes.
implies. Yes.
So if you connect this with implies, if this one is true, to become whole thing true, what would be the value of this one? Definitely true. Am I right? I don't have any other alternatives.
Yes, sir.
Because if this one is true, if this one is 0, then whole thing become false. But we want to make this whole argument as true. So that's why you say this one is true. We assume then this must be true. Then the whole argument is true. So now, if this is the case, then it is called valid argument. So this is called valid argument. This whole process is called valid argument. Is this clear to you guys?
Yes, sir.
Okay, so let's assume I have P1, P2, P3, Pn, statements. Want to prove Q from this. How can I prove that one? Assume I have P1, P2, P3 up to Pn statements. Want to prove Q from this. How can I do that one? What would be the connectives I need to use?
Bidirectional.
P implies Q.
There are n number of statements, not only one statement there. How can you connect all these statements?
By implicate.
Sir, P1 P2 সব মাঝখানে and দিয়ে connect করে তারপরে হচ্ছে implies
Fantastic.
Q দিনা
Wonderful. P1, P2, and dot Pn. This one implies
Q.
Q,
Yeah.
and I have to prove this one is true. That means I need to prove this one is tautology.
Tautology. Yeah.
Tautology. So true means it is a tautology. Right?
Yes, sir.
Now, together this is called hypothesis. The left hand side in this case, whenever we are trying to prove this, the left hand side is called hypothesis. Right hand side is called conclusion. And each one is called premises. Okay, guys? And our goal is to prove the whole thing is a tautology. What would happen if whole thing would be tautology? Then if each of the hypotheses, if the total hypothesis is one or true, what is the meaning of this? If the total hypothesis is one or true, what is the meaning of this?
So we can't see
Huh?
it. It's all pixelated, like distorted.
Yes, sir. It got blurry.
It got blurry.
Yes, sir.
Yeah, sir.
Now,
It's still blurry, sir. I think it's readable.
now it is readable.
No, sir. Yeah, yes, sir. No, sir.
Yes, sir.
Okay. If the whole hypothesis is one or true, what is the meaning of this? If whole hypothesis is one or true, what is the meaning of this?
So yeah,
The conclusion should also be true.
Also,
yeah.
Yeah, that I want to prove. But initially, when all the hypotheses are one or true, what is the meaning of the what is the meaning
P1,
of the
P2, P3, all are true.
all are true? Then actually, I need to prove what? Then I need to prove what? I need to prove this implies
Implies Q.
is a tautology.
yes, sir.
Then what happened? Left side
Yes,
is
sir.
one. Definitely, the conclusion is also true. Am I right? So that is our valid argument. That is called our valid argument. Is the process clear to you guys? We will consider all the premises are true so that the hypothesis is true. Then we are trying to prove it is a valid argument so that the conclusion is also true. Am I right or not?
Yes, sir.
So this process,
Yes, sir.
this whole process is called logical inference. That means logical inference is nothing but a jump, a leap from here to here. This leap is called logical inference. Now, can you tell me a valid logical inference? You know a lot of valid logical inference. Can you give me one example?
Sir, mathematical or real life?
Logical. Logical. Come on. If you take any, see, whenever P implies Q, whenever P implies Q is a tautology, we write P in shorthand. Okay, we write this as shorthand. Now, you know a lot of logical. Let's take the attendance first. Think about finding a logical inference formula. Inference example. Okay. Think. Okay, done. Can you give me a valid logical inference? Example of valid logical inference. Yes, please.
Sir,
You know lot of these formulas. Let me help you a little bit. P implies Q is a tautology. We write this as P valid logical inference to Q in shorthand. So what is this? What is this? What is the meaning of this? Not
Logical
bidirectional.
equivalent.
The bidirectional is a tautology. It means P bidirectional Q is a tautology, equivalent. There is a difference between
Yeah.
these two. This one and this one is a tautology. They are completely different. Whenever you say these are bidirectional, there might have possibility they are not always true. Am I right?
yes.
But when it is a tautology, definitely it is always true, right? Come on. Bidirectional, that does not necessarily mean it is a tautology. Am I right or not?
Yes, sir.
Yes, sir.
Because if it is 0, it is 1, then there is a possibility it is 0. Am I right?
Yes.
And if it is 1, it is 0, there is a possibility it is 0. Am I right? But when it becomes tautology, they are gone. Am I right?
Yes, sir.
Yes. Yes or no? No, yes.
স্যার লজিক্যাল ইনফারেন্সের যে এখানে
Yes,
এই
sir.
বিষয়টা করলেন একটু জাস্ট বোঝায় দেওয়া যাবে স্যার আরেকবার?
Which one?
স্যার এই যে P1 and P2 and P3 দিয়ে যে কিউ করলেন স্যার ইজ এ টটোলজি।
What is wrong here?
স্যার বুঝি নাই আসলে।
এতক্ষণ মানে why suddenly finishing this topic you are asking the question? Why don't you
স্যার
ask earlier?
স্যার আসলে ব্লাড দেখা যাইতেছিল তো মানে এই জন্য কিছু বুঝতে পারি নাই।
Who can explain this to her? Is there anybody? Is there anybody who can explain this to her? Anybody? Nobody? So let's go back. from P1, P2 up to Pn, we are trying to prove Q. How can you prove that one?
স্যার এখান থেকে ট্রাই করবো বোঝানো
How
আমি
can you prove that one? Just tell me the procedure. It will be fine. The girl.
ও
How
অ্যান্ড
can I
হবে
prove?
স্যার,
Why this would be n?
কারণ অ্যান্ড করলে স্যার সবগুলো হচ্ছে ওই সাইডে টটোলজি যে ইয়াটা মানে ভ্যালুগুলো সেম আসবে।
I don't get you. What happened? How come and the tautology value would be same?
স্যার P1 P2 P3 এগুলো যদি স্যার
Forget about all this. Let's do the simplest one. I want to prove P goes to Q. How can you prove that one? From here, I want to prove here. If P is true, this one is true. I want to prove Q is true. How can I prove that one? If P is true, I want to prove Q is true. How can I do that one? Huh? If P is true, I want to prove Q is true. How can I prove that one? Girl,
When P and Q
who asked me
are
the
same,
question? Let her try. If P is true, I want to prove Q is true. How can I do that one?
স্যার
Come on.
পারবো না।
Why don't you try? Try. If P is true, I want to prove Q is true. How can I do that one? Is there anybody who can answer the question?
so when P and Q were the same value,
And P and Q in the same value. So how can I know that P and Q in the same value? If before proving that one, if we know P and Q have the same value, then there is no need of proving. There is no need of jumping. So how can you jump actually? How can you jump? Come on. Is there anybody
Sir,
who can
implies means that Q is only true when P is true. So,
Wonderful. So if this one is one or true, somehow if we can prove the whole thing is one and true, then definitely Q becomes
true.
one or
হয়ে
true.
যাবে।
So that is the procedure, right? Now instead of having only one, this one is called premise or hypothesis. Now instead of having only one premise, I have n number of premise. Then how can I prove out of this n premise Q? Tell me.
So we all can contribute.
All are true. So left side should be always true, right? So how can we join all this n so that this left side would be true?
By n.
I add. So if we OR, then if one is true, then whole thing becomes true. So we have to use n. So P1 and P2 and dot 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 Pn. This one I need to prove Q, right?
Yes, sir.
So the whole thing is called hypothesis, and each one is called premise. Okay, guys. What I need to prove? All premises are true, one or true. Am I right? What I need to prove? I need to prove this one is one or true. So what I need to do? What I need to do from this? What I need to do?
Prove it tautology.
We have to prove this one is a tautology.
Yes, sir.
Or we have to prove P1, P2, Pn. This one is Q. Is that clear to you guys?
জি স্যার এখন বুঝছি।
Yes, sir.
Okay, বুঝতে পেরেছি. So let's give you an example. Then it's become clear. যে মেয়েটা প্রশ্ন করেছে তার নাম কি?
দিশা স্যার, নুরজানা দিশা।
Okay, so let's have an example with Disha. Disha, what is your favorite game? Ludo.
স্যার আমি খেলি না গেম।
Ludo. Let's assume your favorite game is Ludo. Okay? Ludo
ওকে
খেলতে
স্যার।
পারেন? খেলতে
জি
পারেন তো?
স্যার পারি।
Yes, sir. Okay. Disha studies. Let's assume my P is the statement. Disha studies discrete mathematics. Q is Disha plays Ludo. R is Disha fails discrete mathematics. Okay, guys? Now, what is P implies Q? What is Q implies P? Not Q implies P. What is the meaning of this? Not Q implies P. What is the meaning of this? Not Q implies P. What is the meaning of this in English?
Disha does not play
If
Ludo.
Disha
If Disha
doesn't
does
play
not play Ludo,
then
she
Disha
studies discrete mathematics. Am I right?
Yes, sir.
Then what is this? P implies not R. What is this? If Disha studies
discrete math,
she
does not
will
Does
not
not fail.
fail discrete mathematics. Am I right or not?
Yes, sir.
Yes, sir.
Disha, what is not Q? Does not play Ludo. Now, this one, and this one. Using this one, prove this. Not Q implies P, and P implies not R, and not Q implies not R. What is not R? Not R is Disha does not fail. So how can you prove this from out of this? Tell me. What is the how can you prove this? If this one is true, this one is true, and this one is true, prove this. How can you prove that?
We have to prove the whole
Truth table.
as a tautology.
As a tautology. So that is one technique. That is one technique. You are right. So let's try with that one. That is one technique. Let's write this, sir. P Q R 000 001 010 011 100 101 110 111. Then what is the first thing? Not Q. Let's P. P dash not R. Not R.
স্যার কিচ্ছু দেখা যাচ্ছে না।
কিছু দেখা যাচ্ছে না কেন?
নো স্যার, অনেক ব্লারি।
আবার ব্লারি হয়ে গেছে।
অনেক ব্লার হয়ে গেছে স্যার।
Okay.
নো স্যার, এখনো ব্লারি আছে।
এখনো ব্লারি আছে?
জি স্যার, পড়া যাচ্ছে।
Is it clear now?
নো স্যার।
Done? Can you read this now?
নো স্যার।
নো স্যার।
স্যার we have to guess it out.
You have to guess it out.
ইয়েস স্যার।
Should I continue or?
Wait.
Sir, left the left side of the page we can get a bit like we can guess it out, but the right side, the upper thing, is completely not readable. So it's clear now, sir.
Yes sir, it's clear.
It's clear.
Now it is clear. Okay. So Q not Q equal to 1, P equal to 0. So this thing would be 0. Then not Q is a 1, P equal to 0. So this thing is 0. 0, it should be 1. So 1, 1. 1. 0. So definitely this is 1. Then let's go over here. P is 0.
1 হবে।
Can one of it? This one is 0, this one is 1. Definitely it is 1. Then this one is 1. Then this one is 1. This one is 1. Then P is 1. Q equal to 1. So 1. P equal to 1. Q equal to 0. So definitely this one is
0
0. Okay. Then this one is 1. R equal to 1. So 1. So 1
then
is
0
0. Right. Now let's come over here. 1. P is 0. 0. 1. P is 0. 0. 0. Definitely 1. Definitely 1. Then this one is 1. This one is 1. 1. 1. This is 0. Definitely 1. 1.
1 1
Then and this one is 1 1 1 1 1 0. Then 1 0. Okay. And it's end with this one is not Q. 1 1 0 0 1, 1, 1, 0. So this one is 0, right? Because if anyone is 0, so definitely this one would be 1. The whole thing.
So not Q
Not
last side
লাস্টের
because
লাস্টের
one.
ওয়ান কেন? Not
So
Q
একদম last এটা second last sir, not Q.
স্যার রাইট সাইডে যে নট কিউ মাত্র লিখলেন লাস্টের 0 দিয়েছেন, তার আগেরটা 1 দিয়েছেন স্যার, 0 হবে।
0 হবে, হ্যাঁ,
Yes,
0
sir. Yes, sir.
So this whole thing is 0, right? In AND operation, if anyone is 0, the whole thing is 0. So
Yes,
if
sir.
the left side, whole left side is 0, definitely it is 1, right? The same way, this one, that is a 1, 0, so definitely the left side is, total thing is 1. Definitely this thing is 1. Now this one is important. The left side is 1. What will be the right side? Right side is also 1, so whole thing is 1. Now this one is definitely 1, definitely 1, definitely 1, definitely 1. So this is the tautology. Is the proof clear to you guys?
Yes, sir.
Now there's a catch. What is the catch? If I have 3 primitive statements, I need how many entries? 8. If I have 4 primitive statements, how many entries I need? 16.
16.
If I have 5 primitive systems, I have 32. This if I have 20 primitive statements, 2 to the power 20. It is a big number. Okay. Now, if you go back over here, I don't need to calculate truth table for all of this combination. For example, whenever the left side is 0, that means any of the premises is 0. I do not take care of the calculation. Am I right or not?
Yes, sir.
Why? Because P implies Q, whenever it is 0, definitely it is 1. Whole thing is 1. Am I right or not?
Yes,
Yeah.
sir.
So which thing I need to consider?
The left side first. If left side is 0, then it's obviously going to be 1.
1. And so that is automatic. I do not need to consider that one. So which one I need to consider?
If the right side is 0.
If the right side is, no, not right 0. P implies Q. Whenever P is 1, I have to check whether Q is 0 or not. 0 or 1. That is the main important point. Am I right or not?
Yes, sir.
So in this case, which one is the most important point? This one. This one. When the left side completely 1. That is the most important point. That time only I have to verify whether it is 1 or not. And that time it is 1. So the whole thing is a tautology and can write this. Am I right or not?
Yes, sir.
Do you have any question after this? No question?
No, sir.
Okay. Should we stop here today? I think the internet is disturbing too much.
Yes, sir.
Okay,
Yes,
let's
sir,
stop
the
here
internet
today.
is being a problem.
Okay, so let's stop here today. We'll start from tomorrow from this point. Okay?
Sir, is
Take
the
care.
attendance automated?
Okay, sir.
Yes, I have submitted that. Let's see what happens.
Thank you, sir.
Okay.
Okay, thank you, sir.
Assalamu alaikum, sir.
Assalamu alaikum.
Assalamualaikum, sir.
Assalamualaikum, sir.
Sir, hello. Sir,
Yes.